Oftentimes, there are questions where you need to use symmetry to your own advantage when solving it. This is one of those questions from JEE 2023 where I think this point was directly in action. Now, using symmetry is not a trick or it's not something that is frowned upon, especially when you know that taking any general point won't change the property of the answer. And we do that in higher physics or higher mathematics all the time. So, letting go of all that and focusing on the question, we have here 8 vertices of a regular octagon that lie on a circle of radius 2. Now these are the first 8 points. Then let P be another point on the circle and let PAI denote the distance between that point P and the 8 vertices one by one. So PA1 would be the distance between P and A1. Similarly, PA2 would be for P and A2 and so on. So you have to find the maximum value of the product of these distances or the maximum value of the product of the lengths of these 8 line segments. So let us jump into it right away. We take points very strategically here. Okay. So there's a regular octagon. So the angle between the two diagonals would be 360 divided by 8, that is 45. So we'll choose our points such that the line joining the first point to the origin and the x-axis will make 45 degrees. So when you do that, when you keep adding 45 degrees, you get all the points of the regular octagon. And here remember, very important, that the radius of it is 2. So when we choose points, remember to keep its magnitude as 2, because if all of this is confusing, just see this diagram and it will all make sense. So we can inscribe the regular octagon like this. Now remember why I said that you use symmetry here, because if you move this point here, if you move these points here, let's say you rotate Z8 or you rotate this here, so Z1 will move here, Z2 will move here and so on. When you keep rotating this, and then you will have to choose another point P, even then the answer would be the same, but your calculations would be absolutely tedious. So we can just leave all of that and focus on this arrangement. So we will start Z1 from here. And again, you can start Z1 from here, but I've noticed that once you do this, your calculations become easy, because then the point 1 or n is equal to 1 will correspond to this point. If you start from here, then you will take n is equal to 0 to correspond, or n is equal to 1 to correspond to 0 degrees or 0 radians, and then n is equal to 2 will correspond to this one. So there is a chance to make mistakes. So remember this thing for any question. If possible, try to keep your first point or n is equal to 1 in such a way that you do not confuse between 0 and 1. What I'm saying is, if you would have taken z1 as 2 e raised to the power I 0, then z2 would be 2 e raised to the power I pi by 4, right? So when you would write the general equation of the point, so you have zk here. So here you would have started k from 1. You would have to keep some other constant. You could not have kept k here. You would have to keep, let's say, n. So then when k is equal to 1, n is equal to 0. For the other situation which I told, that which we have not taken, z1 would have started from here, then the problem would have been z1 n is equal to would have been 0. But since we have done this, we have reduced this one variable, because when we put k is equal to 1, you get z1 is equal to 2 into e raised to the power I 1 pi by 4, that is e pi by 4, and so you will get this point. Similarly, when you will put n is equal k is equal to 2, you will get this point, then this point, then this point straight away. You do not need to worry that n is less than k or n is equal to k minus 1. You do not have to worry about all of this. Are you understanding what I'm trying to say? So remember this even for other questions as well. Okay, so this is the diagram, and we will have to take another point which is variable p on the circle, and which is different from the vertices of these octagon. And then we would have to find the distance of p from this vertex, then from this vertex, and so on. And then we would have to multiply all these distances and find out its maximum value. So this is how the question proceeds. So here AK, that is A1, A2, A3, A4, A8, that the question has already given to us the name of the vertices of the octagon. We have taken as ZK as 2 e raised to the power I 2k pi by 8, okay, which is basically I k pi by 4, but I have made this so that, again, to preserve the symmetry and ease of calculation, k from 1 to 8, or otherwise you will get confused. Then when you raise zk raised to the power 8 or z raised to the power 8, you would get 2 raised to the power 8, this whole thing raised to the power 8, so 8 would come here. Then z raised to power 8 is equal to 2 raised to the power 8. This is exactly similar to this. So I mean, this is analogous to this, so you will solve it in the similar way. or you will apply the same properties here as well. So finally we have z raised to the power 8 is equal to 2 raised to the power 8, and what are these? These are the roots of the above equation because it came from this, right? Because zk is of this form, so we have come to this from this only. So these 8 values would be the root of this equation, and we can convert that equation into an identity by just writing out the factors like this. Remember that when you write it like this becomes an identity because these are the roots. So whatever value of z you will substitute, it will be true for all values. So now we can happily place p here. P is this point. Now we can happily put the coordinates of p or any random coordinate from all over anywhere around the coordinate axis. We can put it here because this is now an identity and no longer an equation. Now corresponding to the point P, because P also lies on this circle of radius 2 and center, which is the origin, so you will get a pretty simple equation of this circle. Or you can pretty easily write the equation of this, the general locus of this point P, right? Z is equal to 2 into e raised to the power I theta. This is the equation of any point on a circle, right? With center origin. So that is 2 into cos theta plus I sin theta. This is corresponding to the point P. Now it can be a little overwhelming, but just move line by line. So P times AK, that is, we want these distances, right? PZ1, PZ2, PZ3, PZ4. So the general term would be PZK, where K varies from 1 to 8, right? So that is how I have written. And what is the distance between points? This point is Z, so distance would be mod Z minus Z1. Similarly, this would be mod Z minus Z2. This would be mod Z minus Z6, and so on, right? That is what I have written. Mod of Z minus ZK is the length or the distance of point P from each vertex taken one at a time. So this is PAK. Now this is the product sign, right? Product of PAK when K varies from 1 to 8 would be mod of Z minus Z1 into mod of Z minus Z2, and so on. Now here we can directly use this because if you take mod both side, then also this relation would hold true, right? So we have just done that. So what we will get is open the mod for each individual bracket. So mod of Z minus Z1, mod of Z minus Z2, we have opened it for each individual bracket. This is nothing but this product of all of them. Basically, I have just shifted this here and this here. So that's the same thing. We have just substituted 2 into cos theta plus I sin theta here. Okay. So again, I have just written the last two lines again. So this would be, you will take 2 raised to the power 8 common outside, and you know how to find the mod of this, right? You just take all the real terms this side, all the imaginary terms this side, and simply do under root of a square plus b square. So simplifying using basic trigonometry, if you have watched our previous video, we have done the same simplification in that and when, and this is a very standard simplification. These terms become 1, you already have a 1, so you get 2 minus 2 cos 8 theta. Then again you take 2 common, you would get 1 minus cos 8 theta, and you will apply 1 minus cos 2a is sine squared a, right? So this angle would get half. Then you already have a 2 here, so this will be 2 sine square 4 theta. Take this 2 outside, you will get 2 raised to the power 9, and inside you will get only this single term, that is sine 4 theta. And what this basically is, this was the product that we required. This was what we required in the original question, right? The product of distances, we have to find its max, right? So this quantity is max when sine 4 theta is 1 or mod of sine 4 theta is 1. So sine 4 theta can be plus minus 1. It's a mod, it doesn't matter. So this quantity would be 1. Finally, this whole thing is always less than equal to 2 raised to the power 9. That is the answer to our question. So again, the learning from this video was not to take any random points, but to take points strategically. So like with every question, you have to apply or what theory you have already studied from n number of sources, and you have to combine all of that and solve JEE questions. And that is what this channel is all about, to help you step by step understand how to integrate all of the theory that you have learned in a way to solve JEE questions. So we will specifically add value to whatever it is that you are already being taught in all your classes or you have been reading on your own. You keep on doing that, but after that, watch how to solve problems and increase your problem solving capability, because we specifically take questions that require some thinking, that is not exactly the application of formulae, right? You will have to apply some more brain to them. So what you can do it at the end of every day or every alternate day, you can watch one of those videos. So slowly your problem solving skills will develop by watching, because you learn by solving more and more questions, right? And we have chosen these questions strategically. So subscribe to the channel, check out our other videos. Thank you.